Hello, my name is Carsten Rossniffel. I'm the CTO and co-founder of EANTC, the European Advanced Networking Test Center. It's a sincere pleasure to be back in Paris at the MPLS and SDN World Congress, as always. In this year, 2023, all of the remaining aspects of the pandemic have been overcome. It's full house here, it's crowded, it's like we have always loved it. Our Interop event, which has been one of the bigger ones in the last few years. We have had 17 vendors participating with more than 90 devices. 80 engineers from the vendors worked in our lab for 2 weeks in the hot staging to prepare the showcase here and to really gather more than 1,200 results in the end after 2 weeks. An amazing amount of results. And it's overwhelming because the technology has matured, because it's possible to actually run all of these test cases efficiently now, even complex ones where 3, 4, 5, or sometimes 6 vendors were involved. And from the different technologies, just a few highlights. We have seen a lot of innovation in SRv6 this year. 8 vendors have participated. 5 of them have tested for the first time together microsids, like compressed segments, which make the technology more optimized, more efficient. And of course, way advanced scenarios like traffic engineering, like flex algo, inter-domain stuff, and so on were also evaluated. We've also seen SR-MPLS tests we've seen EVPN tests over VXLAN, over MPLS, over SRv6. And in these areas, which are very mature, the focus of the vendors was mostly on optimization, on scaling, and on making things more operational. These are very important topics for the industry, for the service providers to actually utilize the networks in production. Finally, in the clock synchronization sector, an area that we've covered for 15 years, and it's still innovating because it's one of the most challenging technology areas in the telecom transport space. In this clock synchronization space, we have focused on 5G use case scenarios. We focused on open front haul scenarios specifically, where the need for very precise clock synchronization is ever increasing. For example, for millimeter wave deployments, Class D clocks are now anticipated to be needed, and these Class D clocks have shown a precision of up to 5 nanoseconds, and even in a chain of 7 clocks behind each other, chained just because for demonstration reasons, we have been able to achieve 17 nanoseconds precision. So, of course, there's a wealth of results. There is a wealth of data that we're happy to share in our detailed interoperability report. I cannot present all of it here. I would be talking for an hour or longer. But please have a look at our test report. Its goal is to describe everything in detail in a reproducible way, in an as transparent way as possible. And also, if you have any further questions, please feel free to ask the participating vendors or the EANTC team.